Okay, let's take a look at these tests. So we have some basic expressions that we want to be able to parse. Here we've got a constant and we've got a variable name. Let's go ahead and start with those then. So in our parser, we've got a token stream that gets created when we initialize the object, and then we've got our parse expression method. So here we have some simple EBNF. I'll talk in more detail about this in the next part when we add a bunch more structures to our grammar. But what this is basically saying is an expression can be one of these three things: a parenthesis with an expression operator and another expression and a close parenthesis, or a variable or a constant. So in our case, we're not going to worry about the expression yet, just to pass that first test. So we'll say if, let's see, we have our token stream, right? So we're going to get our next token. And then we're going to ask if it starts with a letter, basically, right? If it starts with a letter, then it has to be a variable. So is alphabetic. Next, I get value dot are at 0. If that's true, it's going to be a variable expression. So we'll return a new identifier expression with next dot get line number and its name. And for now, we're going to assume that everything else is a constant. And so this will be next get line number and then the integer dot parsing of what happened there. Okay, so this one probably will work now. Technically, we need some more logic here. If we really want to match Java, I think an identifier can start with an underscore too, and maybe that's it. Just a letter or an underscore. We'll just ignore the underscore and not allow it in Brew just for simplicity's sake. So this one won't pass yet, I'm sure. Okay, so now we're going to start parsing some expressions with parentheses. One problem we're going to have right now is that we need parentheses around every part of every expression. So if we look down here, as these get more complicated, they've got parentheses all over the place. Now, you don't really need all of these, right? If you think about the order of operations, you could get rid of some of these parentheses. But for now, our parser is not going to be smart enough to figure out the precedence, the order of operations. So we'll need parentheses for every binary expression or every compare expression that we interpret. So here, if this token is a parenthesis, then we know we're doing a binary expression. So we're going to say, okay, we already removed the parenthesis. So then the next thing that will happen is we need to parse an expression for the left sub-expression, right? So we'll say parse expression. This is where recursion really fits well with writing the parser. And then we've got the operator, so we can say it's token again. And then we need to be able to create, is it operator dot from symbol? Now we need to be able to create an operator from our operation symbol that we've got. So let's see, what do we got here? Operator has a, yeah, from symbol method. This is the one I was looking for. So there are a couple of kinds of operators we can create here. Binary, that's binary expression. Where are the operators? Oh, they're down here, aren't they? They're under opcodes, I think. Yeah, binary operator. We already have, I've already added these symbols. These were not here before this part. But now that we've got those, we can sort of follow the pattern we used here to create operators from instructions, and we'll create them from symbols as well. So basically this is what we want to do. And this is going to be ops symbol. And then here we'll do the same sort of thing. We're going to put the op in the map under the symbol, and then in this from symbol, we can do ops symbol back there. All right, so that will uh, let us create the operator object from whatever symbol we ran into in the code. And then later when we create an expression here, for this one, it's an arithmetic operation, so we want a new binary operator or binary expression. We'll get the line number left on this is the operator and right. And then we need to do the same thing for compare branch operator, basically. So this, we need ops by symbol. And this will be still a string. And then here, let's get the symbol. And then we need to get it here. And we need to create an expression. Now this one is a, what's this one called? It's called it's still a binary expression, isn't it? Yeah, it's exactly the same type. The binary expression class supports operators of either of these types, so binary operator or compare branch operator, which is why simple operator exists. So this is a base interface just so that those two things can be treated as one type. And then when we look at binary expression, you'll see that it holds a simple operator. Okay, so we got that part to work. Now in the brew parser, we can use it. So we got our op token. Now we want to say operator dot from symbol op token dot get value. And this will be an operator. And then we've got our left child, we've got our right child. We need to consume our we need to consume the right parenthesis, right? We're expecting a right parenthesis after this, and it must be there, so we consume that. And then we're going to return a new, actually, no, we're going to say op.create expression and give it the line number, which will be, so this is a little tricky. Later on when we're debugging, the line numbers are going to be important. And you could spread an expression across multiple lines. So what we really want is for the line number of the expression to be where the operator was, right? So it'll be op token.get line number. If the left child and right child are on different lines, when we're stepping through the expression, we really want to be in the line with the operator itself when we're about to perform the operation. Okay, so now we're going to create an expression with those left and right children. And I think this will probably work. Not yet. What are we missing? And we cannot, it's a null here. I guess op was null or something. Let's see what happened here. So did I not fill an operator? I didn't fill an operator from symbol. That's okay. So here we need to say op equals binary operator from symbol. And then if this exists, and then do the same thing basically for the compare operator. Yeah. Now what? Still getting a null somehow. Is that just the test line to me? It's not. Let's see what happens. Okay. We got our op token, which is a plus. That seems good. We're going to go in here. And it should be binary operator that has it. Ops by symbol did not get populated. Oh, yeah. Okay. Made a mistake here. This needs to be ops by symbol, and I bet I did the same thing in here. Yeah. Okay. All right, so there we go. We're parsing expressions. Um, this is actually pretty cool, right? We didn't write a lot of code here in this parser. Just a few lines of code here, but we're parsing really big, complicated expressions, right? Things like this. This builds a big tree of expression objects, and recursion just takes care of that for us, right? We don't have to think about it. We just sort of look at the structure at the node we're looking at in our tree and build that node and don't really worry about